Okay, let's officially start with this webinar. Thank you for coming. Today we prepared pretty interesting topic for you. So the topic for today is preserving cultural heritage with photogrammetry, tips and trick. Super interesting webinar and I'm pretty excited. Thank you for coming. Today is with you Marko Mesaric. I'm a land surveyor with more than 11 years of experience based on photogrammetry technology and of course also traditional land surveying technology. I've worked already more on 1,000 plus projects, so every day or every second day we get some interesting project to work on it, or one of our customers send us the project and we help him with it, with the processing and so on. So we have some experience to share with you. I'm also product manager at 3D Survey, and because we are flying drones almost on a daily basis, and I'm also trained drone pilot operator. If there are some questions during the webinar, please set your question in our question box. Should be on the right side of webinar platforms, and I will try to answer those questions during the webinar or at the end of the webinar. This webinar will take us approximately 45 minutes, and if there is anything, feel free, ask us. If there is something more advanced or you will not be able to ask in the webinar platform, you can always send us an email on support@3dsurvey.si and we will reply on this email. And if we go right into it, today's topic is cultural heritage, but you can use also the same approach for any other 3D objects to map them. So first, I would like to start with short project description. We have two examples here. The first one is monument, and the second one is old city center. So road in a length of 150 meters. And I would like to describe you really quickly what was the project about. Then on our second point, we will see equipment description, what kind of equipment we use for these two projects. Then we will spend a bit more time and show you how to set your camera before the flight. So first we will look about the camera settings, and then we will show in the software instructions for data acquisition. So how we actually map those two different objects to get the best possible results out of it. Then at the last, basic workflow in the software, and of course, result presentation. After this, I will try to answer on your questions. If there are some, please feel free to write them in our question box. But before we go right into it, we prepared also 3 questions for you that I will see what kind of audience we have today here. And the first one is already on your screen. And actually, I'm asking you from which industry are you coming from, so that we can see what kind of audience we have here. So let's wait a couple of more seconds to get results from you. Okay, we have already more than 60% of the answer. And if I conclude, the first question is 70% from surveying industry, 10% from construction, 3% from documentation, and the same from mining, and 50% from other. Okay, I will close this pool and set your second question. Did you already try 3D survey software for processing? A super simple one. Are you already our customers? Yes or no? Or no, I'm using another software, just to have idea what kind of things they're doing and so on. Let's launch also this pool so we can start with your answers. Okay, first answers are coming. Really interesting. Already 60% of you already answer it. We are at 70%. Okay, so, and we have 57% yes, you are already our customers, happy to have you here. 20% no, and 25% no, I'm using another software. Okay, pretty interesting one. And let's start with my last question. And this one is actually, how many projects per month are you doing with this technology? So how many projects per month? 1 to 5, 6 to 10, 11 to 12, 20, or I'm still not using this technology. Okay, few more seconds to get the results. Again, already 70% of you already answer it. And the first one, so 1 to 5, 55% of attendees, 6 to 10, which is already pretty much 10%, 4% actually, 11 to 20 projects per month, really good. And 31% of you are still not using this technology. Hopefully I motivate you to go right into it, this technology, and see how powerful it is. Thank you for your questions, and let me continue with my presentation. And I would directly like to start with my first project. This is kind of 3D documentation of a monument. The object size is approximately 2 per 2 meters, and the height difference from the lowest part to the highest is about 7 meters. So this is kind of an average monument which can be mapped. Those could be smaller or bigger, but the approach is actually more or less the same. Okay. What's the specific of this one? The monument was in the middle of the street, and on the left side and right sides were buildings. So it was actually almost impossible to fly in automatic mode. That's why we try to fly manually. We place 4 ground control points to do the orientation. Later on, you will see we use the Phantom 4 RTK drone to map this scene. And actually, because there were not a lot of space there were trees in additions and all different objects, we decided actually here to fully manually fly the drone and trigger the camera manually. So this gives us actually really great control over the drone. Also, in most of the mission planning software, it's not able to fly autonomous flight on 10 meters or even lower. I think the minimum height for the DJI Phantom 4 RTK flying mission is 25 or 20 meters. So this was another reason we decided to fly manually. But if you are actually trained a bit to fly with the drone, this is nothing special. So we fly with the GPS support, with everything, so you can always really nicely control the drone, and everything is pretty much controlled. Then fully different example where we need to map 150 meters of road with the building facades. Different approach. In this case, we need to deliver 3D textured mesh with the video presentation, and the resolution of this model should be around 2 or 3 millimeters. So we need to fly pretty low, close to the facades, and so on. And we decided here for a bit different mapping approach. First, we do a double grid mission with the help of a DJI app, and then in addition, we also add manual images with manual flight. We will spend quite a lot of time later on to see you how to map this one. This is also my main goal for today's webinar, that you get a good feeling how to go when you need to map something like this. GCP setup, in this case, we place 8 ground control points for orientation. We could place less ground control points, but we go just double the safety. Because we have an RTK drone, only 1 ground control points probably would be good for such a small area. But when you set up your GNSS device, then you measure some in addition, and that's it. What's the specific of this project is that the road is wide approximately 5 to 7 meters. So we taking care also the side images from the facade to get a really perfect facade. Then these are old buildings where have also a lot of details under the roof. So we trigger also hand images with drones. So I actually hold the drone in one hand and triggered with another one and actually pointing the camera up. So in this case, we add also additional images, and at the end, we have approximately 1,200 images to calculate this example. Okay, our equipment for these two projects was Phantom 4 RTK. You can see the drone here. Then we use like a GNSS device, so the GPS system for measuring the ground control points. We use our 3D survey targets, so black dots on white plate. When you have such a great number of images in such a small area, usually one target is on 100 images. And if you need to correct the position manually, this is sometimes really hard. That's why I warmly advise that you use our 3D survey targets, and then the complete workflow is super automatic and fast. And of course, we process everything in our software, 3D survey. Most of you probably already know the software based on the pool. And I process this actually everything on my on my laptop computer. I have an Asus ROG Zephyr computer with 16 gigabytes of memory, so standard laptop computer. It has a good processor, AMD, and I have a NVIDIA graphic card 260 RTX for the laptop. So the laptop costs approximately 1,500 euros and works everything really nicely on it. Okay, this was about the project description. Now I would like to spend a few more minutes for camera settings before you go and do your projects. And our general advices are actually do first 10 projects on auto camera mode. So if you're not expert in a photogrammetry, or you just use your mobile phone to produce some family photos or anything like that, that you don't understand how the shutter and ISO value and everything works on the image, then we always advise to our customers, do first 10 projects on auto camera mode, and you will definitely get good results. And then when you have better idea how everything works, so after these first 10 projects, use the shutter priority option. So this means that you actually set the shutter type, shutter time fixed value, and then the aperture will change, depends what you're actually mapping. If you're mapping grass or white rock, or I don't know, asphalt areas or open pit mines, the value between colors can really differently, really nicely. And that's why the shutter priority is probably the best possible option to get out the best results, even better than with auto camera mode. And below, you can see the general guidelines for 4 seasons locations. So Slovenia, we have spring, summer, autumn, and winter. And these are just general advices. Okay, if the weather changes, so if you have sometimes really cloudy weather or strong sun, then this can vary a bit, but generally we advise you to use the shutter speed in the spring 1 per 1,000th of a second if there is not a raining day. Okay, during the summer, in most cases you can cover in 1 per 100 seconds, 160 seconds for the shutter speed, so even shorter shutter time. If there is a really strong sun and white rock, because white color is really brightening, then go even to 1/2000th of a second or something like that. Okay, then in autumn the same like in spring, 1,000th of a second shutter speed time. In winter, usually in Slovenia we have really low weather condition, and if the area is not fully covered with snow, which is also white, okay, then you will probably need to set to 1 per 100th of a second shutter speed. This is also the longest shutter speed time that the image is not going to be blurred. Okay, the problem is if you set the longer shutter type, the drone is triggering images during the data acquisition, so during the flight, and then the images will be blurry because the shutter speed is open too long. Okay, that's why never go under the 100th of a second, and hopefully you will have good light. Okay, there is also a third option, how to set your camera parameters, and I actually did go out and record this, and now I would like to share this with you, how it goes, that you will have a better idea. Okay, one option to set your camera parameters is that you actually try the best possible value before you go flying. What you need to do, you need to have your drone. You could have drone landed on Earth and check the value, but better is that you actually turn on the propellers,
take off,
and start your flight manually. I will go up to, let's say, 10 or 50 meters to have more realistic view. Okay, right now I'm on 50 meters. Now we can go and see the screen, what I can see it actually. Okay, like so. I will turn the gimbal down so to have the camera view perpendicular down, because I will map in these settings, and I will go to camera settings here, and I would like to select shutter priority mode, because with the shutter priority you actually fix the shutter time, and then the aperture is it's automatically recalculated, and also the ISO value is recalculated. You would definitely like to have the ISO value 100, because this will give you the best and accuracy of the model. The aperture can run from 2.8 to 10 or 11, currently it's 11, and shutter priority should be between 100 to 2000 or something like that. Depends on the weather condition you currently have. Never go under 100 because in this time, because the image could be blurry, because you're usually capturing images during the flight. So take value from 100 to, let's say, 2000. And how to check which one is the best one? When you're up in the air and you have your area of interest under it, just move this value. Currently we are on 640, and the aperture is also 4.5. This is already good. Let's try to go to the lower aperture value, which is 2.8, and this is then the safest way. We have 3.2. In 2000 it's already 2.8. Now if I would increase the shutter priority time to 250 or something like that, the images could be too dark. Okay, that's why I will go back to 1000, still 2.8, 1250. We are at 3.2, so I think this would be the most optimal settings for my flight. And this was just a test. Now I need to land my drone, plan a mission, send the same parameters as I already showed you before the flight, and then we can easily start with our flight. Okay, so this is one of available options how to set your best camera parameters before you're flying the mission. Okay, we are back from the field, and I already get some questions from you in connection with the camera settings, and I would just love to read them. So I saw the shutter speed is very high. Why you use this speed? My very highest experience say not more than 1/500th of a second. Okay, so Filippo, if you go shorter time, it's not a problem. You will just get you will just get sharper images. Actually, the problem is if you have too longer shutter time, the images would be blurry. So don't worry. If you have strong sun, if you have good enough, you can increase it to 1/1000 or even more. So it's not a problem, never. But take care the ISO value during the flight should be always at what 100 or 200 highest. Okay, so feel free to shorten your triggering time if you have options. The second question is, will the webinar be recorded? Yes, the webinar is recording. You will get the recorder and everything like so. Okay, this was about the camera settings. Now we are already ready for presentation of our two models. And actually the first one will be statue. We will first have a look about the mapping model. I'll try to explain you as much as possible how I did the mapping for this one. On the left side, you can see already the video recorder results from 3D survey. Then we will first look image preview, how I trigger images. Then we will do a quick processing workflow. So we are not going to wait for any processing. I will just go step by step further. We will check the results and generate presentation video. Okay, and we will do the same for both examples. Let's start immediately with our first one, and then continue with the second one with the old city town. Okay, here we can already see our first object of interest. This is a statue on the street in between buildings. The dimension of this statue is 2 per 2 meters, and the height difference is around 7 meters from a lowest to highest point. We also set 4 3D survey ground control points. It's great that if you have our targets, those are automatically recognized and you don't need to manually correct some positions later on. In this case, as you can see, we have a bit less than 500 images, so this is quite a lot, and orientation with the 3D survey targets, it's just faster and more elegant. Because the statue is in between buildings, we decided for manual flight. We didn't use any circle option or any double grid mission, something like that, because the plan was to fly on at least 20 or 25, yeah, let's say 20 meters highest points, and then go lower and lower to 2 or even 1 meters above the terrain. And this is just not possible with the mission planning software. That's why we decided to fly manually. And before we go and look how we fly, I will just go image per image. Then you can get quite good a feeling how I was actually triggering images. So first I decide to nadir camera view. First 10 images, for example, this is the same like you would map any ordinary road or a city or anything like that. So the camera fully down, and later on, to get good details from the statue, I decide for manual circle flights around the statue, and always pointing my camera to the center of the statue. I'm moving now between images that you could get idea how I was actually triggering camera. Okay, now I go even lower. So actually the first nadir images were from 15 or 20 meters, something like that. Then I go 5 meter lowers on 10 meters. Now I'm already on, I think, 7 or 8 meters or something like that. Again, trying to manually fly the nicest circle around the statue and trigger every 10 degrees or something like that my camera. So this is just based on feeling. More images you have, the nicest model you will get on the end. Okay, so don't be afraid. Of course it takes some time additional for the processing, but nevertheless you would like to have all the details. You need to have captured statue from all perspective, even from lower, above, and so on. So that's why I was focusing to get really good images. What was here really difficult was weather, because it was super strong sun I managed to set cameras pretty well, but then shadows came, and this was super difficult. Next time, if I would fly that kind of objects, I would definitely go in a light cloudy weather or something like that, not to have such a strong shadows, which at the end affects on the end results, not actually connected with the accuracy, but more with how visualized it is, how good can you see all the details, and how nice it looks out. But nevertheless, you will see we get also pretty good results also based on those data. So I'm still moving the images, and we are just, as you can see on the right side, on a 1/3 of the images. If I scroll a bit down faster, then you can see I go even lower and back up. Let's go even lower at the end. Let's go fully down. I was actually holding my drone in hands and triggering with the other hand to get also good detail. Okay, here I was still flying. You can see me in the back. Okay, like so. Okay, nevertheless, if we go to our telemetry view, sparse point cloud view, which is a result after first 3 steps, so bundle adjustment, orientation, reconstruction. I will skip the workflow description for this part because you have it in most other webinars. Let's focus now on the important topics. Here you can already see our sparse point cloud. If I turn the camera text down, that you can see better, you see in the center our statue, beside are already some buildings, and all those blue pyramids are actually camera position during the image triggering, and where and how the camera was actually pointing. The pyramid shows us where the camera was pointing. And as you can see, I managed to fly really nice circles around objects, and there is, let's say, 50 or 20 circles around it. And then at the end, additionally, hand shots with the same drone, so with the Phantom 4 RTK, I was holding the drone in the hand and add even more details to the lower parts, and of course also to the higher parts from the low perspective. So in this case, I triggered 473 images. Most of them were registered. You can see it here, 433. About 40 images were not registered. Probably the camera was not pointing in the right direction, or the resolution or the images were blurry or something like that. But nevertheless, more than we need actually. This model is also already orientated based on 4 ground control points. You can see them here, 1, 2, 3, 4. And the next step is reconstruction step. And after the reconstruction, it took on my computer, which is a standard laptop computer with an NVIDIA graphic cards, I think it took me about 4 hours or something like that. And I get around 40 million points from the statue. Okay, so we can see the result already here. Super nice detailed. I already cropped the results, so I get even a bit more if I go undo. Let's see what was the basic point cloud after the calculation. Oh, okay, so yeah, by default we get that kind of point cloud because we don't need here the building facade and so on. I did select part of the my area of interest and use the delete other function. So with this approach you can nicely, really quickly delete everything else what you don't need and focus just on your area of interest. So in this way, okay, let's press escape to get the realistic colors back. Now we have a bit more than 40 million points here again, and if I zoom in with a double mouse click, on a detail. As you can see, already point cloud is here super detailed. Okay, and this is of course the basis for calculating the textured 3D mesh. So this is our next step. If I go here, mesh, calculate new full 3D mesh, I get that kind of mesh here, which is already calculated. We don't need to wait additional hour or two, and this is already our end result. Okay, so those are actually triangles which have a realistic texture on it. If I turn on shading and show grid, we will see how small they are. Actually, the smallest detail is here automatically generated and digitized. So in this way, then we have of course also height map options to see the details. In addition, if you like to change of color of the scale from the height map, just click on the scale and you will have different available options. Like this way. Okay, let's go back to texture and what can we do with this one? So in this project we need to deliver to our customers 3D model of a statue in an OBJ file format. So nothing else as go to mesh, save as, and select the OBJ file format. So here it is, OBJ statue, and click on save. Additional some settings, yes, we will save texture. Let's have the vertex colors also. Those are actually default settings. I leave it like so, and we are already saving our statue. After we finish with the saving, I would just like to show you in this case additional feature which is also integrated in 3D Survey, and this is actually recorder based on which you can produce really nice stunning videos. Okay, the OBJ was saved, so here we have the OBJ and all the textures in addition. Let's just minimize this one and let's go to our recorder. Some of you already know this one. I already have here 4 saved flying pads. I will just create a new one. Let's say test 1 and go to cameras. And now what I need to do, I just show my first flying position and add camera. So this will be the first view of the camera. I will do first one circle, second view of the camera doing the rendering, third view, fourth view, and now let's go a bit lower, zoom in, another camera, then let's move it like up. So if you double mouse click on objects, the viewer will focus on this part. It's a nice example. One, and let's go out a bit. Okay, and let's finish our flying path for the recorder like so. Add next one. We see already this white spiral which shows me the camera view. Let's see what kind of preview I did. Camera 1, camera 2, then we will fly like so. 3, 4, 5, 6, 7, 8, 9, 10. Okay, if I set the duration, let's say 20 seconds, and click on the preview, I get a good idea how the video will look like at the end, and this is a nice way to share the results also with your customer, friends, or anything like that. Okay, cool. So the last part is a bit quick. Let's move maybe to this closer camera and zoom out a bit already, so like so, and modify this position And again, the preview. This is all good right now, flying really nicely. If I would like to go slower, I just need to extend the duration time. So maybe let's set it here to 30 seconds and record the video. Output file, test 1, save, confirm. Okay, and we are recording the video. This will take, let's say, maybe a minute or something like that. And at the end, we have a really nice compressed MP4 video, which you can share with a email, drive, anything like that. I would like to mention the idea is to show this OBJ file at the end in some kind of open platform. I think they will use a Sketchfab, and then you can put some annotation on it with the short descriptions or anything like that. And it's a really nice way to share those kind of objects with a broader audience, so anyone can see what you have to show them before they go and visit it. It's a nice touristic promotion thing or anything like that. Okay, we have a video, and here it is. Just double mouse click on, and this is our result. What's interesting to know, during the recording you could switch to different view styles. So if you like to go show grid or hide map or camera in addition, you can just press buttons on it and everything will be recorded. Okay? Cool. This was our first example, statue in the middle of the street. Let's go to our second example, old city center road with facade in a length of 150 meters. Okay, here we have our second example, fully different to the previous one. In this case, we have a situation of road in a length of 150 meters. It's actually in an old town city center. Let me maybe change the view to zoom in a bit. You can already see a lot of camera icons. On every icon the camera was triggered, and when we have been deciding actually for a flying method, we decided to do first a double grid mission flight. You can see this one here in a telemetry view, and then add also a lot of manual triggered images. We can see here a really big height difference in between. The thing was, here we have a RTK signal and accurate position, then we turn off the drone and start with manual flight. We didn't get a RTK position and the height was not calculated referentially correctly, but nevertheless we get the end results like you can see it here after the bundle adjustment. So all cameras are after the bundle adjustment correctly positioned. You can see we use also 1, 2, 3, 4, 5, I think 8 ground control point targets, and those blue pyramids nicely show us the position of cameras. So here first double grid mission. Let's maybe deselect this one. Okay, so this was the double grid mission, and then I just go with a manual flight, flying in a row, turn on the camera a bit down and trigger side images. And the first double grid mission was on 35-meter flights, then I go to 30 meters, 25, 20, so every 5 meters I go lower and try to do best side images to get most of the detail out of it. The end results must be pretty detailed, accurate 3D models with a resolution of 2 or 3 millimeters, so super accurate. We also have some special objects here, so it's hard to visible right now, but here are some kind of horses' heads, like a small statues, 4 of them, and I actually managed to combine those aerial images from 35 meters to ground images which are triggered with the same drone with the Phantom 4 RTK. Manually I hold the drone again in my hand and trigger cameras. But the important thing is you need to connect those two heights in between. So don't go 35 meters and then on 2 meters. You need in between 20, 10 meters, 5 meters, and so on. And if you do this successfully, you get such a nice result of the bundle adjustment. Before we go and check also the point cloud, I would like to show you just a quick overview between images, how they were actually triggered. This is now the double grid flight on 35 meters. Here we can see those small statues, horses, which we did a lot of circles later on also Nadir audit. Okay, I think we have approximately 200 images with the manual mode, with the automatic mode with the double grid missions. Here we are still in double grid. Even if I select just my city center of the road, the drone goes and capture a bit wider area, so we have definitely too big area capture, but nevertheless better to have more data than less. And then when I start with my manual flights, let's go a bit further down. Here we are still okay. I think no, still double grid. Okay, still double. Okay, here we can see by the name. So this was the planet flight mission, and here DJI 001 I start with manual flight. And as you can see, I try to fly parallel to the road, turn the gimbal angle to, let's say, 45 degrees or something like that, and just trigger images every 2 seconds or something like that. I need to have really detailed images because the end model needs to be nice. Here we have also nice weather conditions, strong sun, a lot of detail is visible. Even better, as already mentioned in previous example, it would be a light cloudy weather when we have diffuse light, no shadows. This will be even better. And in this way I was just actually triggering cameras. So right now I'm pretty low. This is probably from 5-meter heights. I turn the camera fully up also to get also these details right under the roof, which is hard to get from the air, and finish the complete data acquisition for this site. What's the specific of this road? It's an old city town. The road is, I think, 5 to 7 meter bright, so not a main road, and actually you need to be very careful when flying not to hit something. There were some cables, lights, and so on. So after you are above the roofs, you're pretty safe. When you go lower, take care not to hit something, but everything was pretty controlled. I used actually for this flight 2 batteries, so it took me to capture those images approximately 35 minutes or 40 minutes. The first one was fully automatic, then 1 battery manual flight. And altogether, as you can see here on the right side, I had 1257 images, and most of them were actually registered. Okay, later on deselect some of them, that's why I see here selected and deselected, and I'm just still moving between the images that you get good idea, really good idea how to capture your images for best 3D models, to calculate out the best object for documentation and 3D. So every part which is visible on at least 3 images will be later on also on the point cloud and textured 3D mesh. Okay, still moving between images. So this was everything done now manually during the flight. Let's go a bit lower to see if I did something differently. Okay, again the other side. It's great to have also these details under the roof, otherwise you are just not going to get data here. Yes, and okay, then we have some statues here. Then I focus also on this part of the area. For smaller objects, like we saw it already before, the circle flight around the objects is the best possible option. And let's move a bit down maybe. Here we have those horse heads, so also circles around the statue. Again, too strong sun, pretty strong sun. In a light cloudy weather this would be even easier. Okay, then I'm moving to the second one. Again, view from the top down, then from side, and circling around and so on. Okay, so hopefully now you have a really good idea how I map this area of interest. Then I did bundle adjustment, orientation, reconstruction, and after the bundle adjustment I got that kind of sparse point cloud and orientated cameras. I finished the orientation also with the ground control points. You can see my ground control points here. The accuracy was sub-centimeter or something like that. So we can see it here, 11 millimeters, 19 millimeters, 4 millimeters. So super. There was one point moved during the flight. That's why I eliminate this one. This was point number 12. I figured out this after I was collecting back my ground control points. Maybe just really quickly show you, I also use here 3D survey ground control points, and here you can see one from 35-meter heights. Let's try to find another one. Okay, here are two actually. I just lay them left and right side on the road and that's it. So standard setup, and accuracy perfect. Then reconstruction was done here on high level. It took me for this example approximately 10 hours or 15 hours on my computer because I have a small laptop computer, actually Asus ROG Zephyr 14-inch laptop with 260 NVIDIA graphic cards inside. So let me turn on my computer specification. So we have a pretty good processor in my computer. It's an AMD Ryzen 7. I advise you to buy those ones. Are super nice, fast and not expensive. I have 16 GB of memory. This is pretty standard, not much. SSD disk helps me to speed up, and the graphic card is really important. So RTX 260 with Max-Q design because it's for laptop. If you have a standard RTX, will be even faster. If you have 3060, 3070 or something like that, you would be twice or triple faster. Okay, back to results. This was on high calculated. I could go to extreme, and if I go to point cloud, the point cloud looks like so. We have currently here 168 million points visible, and if I zoom in a bit, you can see already from the point cloud we have a really nice detail out of it. I could even read here what kind of road it is. Of course, on the glass we have some noise, but not a problematic ones. Also, all the facades from the buildings are super detailed already on point cloud. So even under the roofs I have good enough detailed to extract later on the accurate 3D textured model. And after the point cloud I just go straight forward, mesh, noise, select, calculate new full 3D mesh. And here I used actually calculation level high. I think I set it to 4 million points, and texture resolution in my case was just half because I don't have enough memory in my computer. I would need 32 or 64 gigabyte of memory. That's why I set it to half. So we don't have the full resolution. If I would like to set to full, I would need to buy additional memory to my laptop. And then, okay, if I show you my mesh, which is already calculated here, it looks like so. This is kind of triangulated full 3D mesh here right now. Okay, let me click also on show texture, and now we have also texture on it. And here we can see how detailed everything it is. Okay, facades are nicely visible. I can read the name of the road out of it. So this is actually a half resolution texture. With a full resolution texture would be even nicer. Of course, we can have here different height mode available, or grid styles. If you click on the height map scale, you change the views and so on. We also get cables inside in this model, so those are power line cables. I could delete them all from the point cloud and then they wouldn't be in my textured model, but I just go straight forward inside. And yes, let's move down the street a bit. You can see super nicely. Here I need to start my mission 3D model. Okay, if I turn in addition also my cameras on, you can now see all together, so mesh with the camera positions, how everything looks. And here maybe pretty interesting things. If we see this scale between images of 35 meters and images from 2 meters or even lower. Here we have a nice model of our horse. There's another one. So we managed to get complete model for our area of interest. Let's see also this one. Okay, cool. Hopefully you have now a great idea how to map that kind of objects. We saw now two scenarios, so the monument scenarios and now old city town, old city center. What can we do now in addition is, again, as we did previously, turn on the recorder. I will close my function window down to have the brighter view. Now we'll add this camera and let's say fly like so, then like so, further down, okay, like so, one turn around and back to the other side to one detailed area and another circle here around, really fast one. Okay, and let's say this should happen in 45 seconds. Let's see the preview mode. I could add also maybe camera positions in addition if I like to visualize them. Of course, cables could be removed before the recording, but this is just to show you how it goes and how to work. Okay, and in this way, if I click on recorder, I would record my MP4 video, the same as we did before for the statue example. And this is already one deliverable which I need to bring to my end customer. And of course, the second one is textured 3D mesh. Okay, so really nicely. I'm not going to record now this one. What is good to know, I think I already mentioned before, when you do the recording, you could change these view styles if you like, not a problem. Also during the flight, you could even go to point cloud view if you need to go, and back to mesh, and what you see is what you get, so with the recorder. Okay, let's stop the recording. And yes, the end results of this one is, let's go to mesh, save as, and set OBJ file format. You could use also Collada, STR or something like that. Depends what your partner want to have. So we have a broad available option of exports. Okay, this was from my second example from the mapping old city town, and hopefully you get a good idea how it works. Okay, so we are already at my famous part, so questions and answers from the audience. So hopefully you like this webinar or presentation and so on. And we already have some questions ready for you. Let me just maybe copy this table that you will be able to see what kind of question we have. So compliment very nicely. Thank you very much, Filippo. We answered already this one. Then we have first question. Did you use scanning, or this is purely photogrammetry? Did you use some noise filtering for point cloud for this presentation model? Okay, so yes, this is purely photogrammetry, no LiDAR data. If you have some LiDAR data, we could combine it in the same software. So we have also these possibilities. But because here we have really nice textures, already the photogrammetry results is gorgeous, so no need for laser scanners. Then if we need, if we use some kind of filtering noise from the point cloud, all the results you just saw it were fully automatically with no filtering out of it. So this is the pure results from the algorithm. I must say we have a really nice, really advanced algorithm for point cloud reconstruction in comparison to other softwares. And there is really minimum value for noise. So if you have some, in addition, filtration options, or what I could also do some classification or manually select and delete a bit of noise out of it. Of course, I would get even better end results, definitely. Okay, then hi, next question from Mateos. Hi, is it possible to change the recorder settings so that the dunless of the camera movement is constantly all the time, speeding up towards the end? The video often does not look good in the presentation, the results. Okay, so what we are doing here, there is some kind of clever algorithm which calculates the speed. In the presentation, this was really quickly done. I just click so. I could improve the position of the last turn, so the camera will go actually more smooth around it, not too fast. It's automatically calculated. It's not possible to set the speed between the segments because, but we could improve this, of course, also. But in most cases, I must say that if you set your camera views normally, you should get nice results out of it. Okay, another interesting question from Eleni. I get an error when creating the mesh. Input point cloud has no normals, which are requirement. How can I add then normals to this workflow? Yes, probably you import the point cloud from laser scanner, which does not have a normals. To calculate of mesh, we need actually normals. How to overstep this one? There is one software called MeshLab. You could calculate their normals and import them back, or you just wait for next release in which one we actually plan to add this calculation of the normals. And then you can also create texture 3D mesh for LiDAR data which don't have a normals inside. So we are working on it to make even easier for you if you have laser scanners and would like to create nice surfaces also from laser scanner data. Okay, the shutter speed was already answered. Then the next one is which angle did you use for circular projects? I'm not actually so much focusing on the angle when I'm triggering images. I'm more focused on a flying height. So if I go to 50-meter flying height, then I turn the gimbal so down that my object of interest, which I would like to see, is in the center of the camera. But if you don't have a feeling or something like for this, some kind of 45 degrees camera angle is the more stable one. Important to know, if you like to connect 90 degrees cameras and 45 degrees cameras, I would advise you additional one circle, so with a 75 degrees angle or something like that, to really connect all the cameras, the same as you saw already in our presentation. So this is the most standard way. Okay, these were part of my questions. Do we have some in addition? If you like to ask something, feel free. I know we are already at 1 hour, but let's go really quickly. Surveyors for surveyors, Judith Saknego, thank you very much. What was the purpose of this mission in the old city center? The purpose was actually archaeological documentation of the facade buildings. So now they have everything digitized. They will import these 3D models to Sketchfab and share with the worldwide what kind of nice streets do they have. And another way is to preserve the cultural heritage, actually. And this was the main purpose, to create a textured 3D model in an OBJ file format. Okay, then we have Mateos told me that this error comes usually after the classification, so could be that you are already using a photogrammetry point cloud. Please send us email with those mesh normals to support, and we will check this out. Okay, needs to work definitely. Okay, let's see what was the okay, which angle. This is already done. Okay, I think I answered most of the question, if not all of them. In case I missed someone, please send me again the question on support at 3dsurvey.si, and we are more than happy to help you. Don't forget to visit our webpage. All the webinars are there. We have a really powerful tool already there. Just go under the learn and I think webinars, and here you can see all the other webinars which were already recorded, and you can watch them anytime also. And of course, if you're still not using 3D Survey and you are not in our 3D Survey family, feel free to try free trial or buy directly, anything like that. If I can help you somehow, feel free to contact us. Nothing else for today. Thank you for listening. See you. Bye.